Okay, so I'm impressed that this number of people are coming in to watch a talk on testing, given that there's lots of kind of sexy stuff going on, except for the fact that yesterday, obviously, I gave a talk about failure. There is a kind of a natural kind of symmetry to this. Now, I'm not going to teach you how to get rid of failure. That would be wonderful. There is no silver bullet. I have that in another talk. This is about the structure and interpretation of test cases, specifically unit tests. I think it's great to see so many people in a talk on unit testing. I have been doing this long enough that I can remember when proposing a talk on testing gave you one of two outcomes, either rejection or an empty room, so you could have a rest. But these days, people are paying a little more attention to this. Now, I'm going to choose a number of small examples. And before people sit here going like, oh, he's only choosing toy examples. You're right, I'm not choosing code bases that are 10 million lines long. You are exactly right. Those are surprisingly hard to actually put on a slide. But it turns out that there is a fundamental thing that a lot of people do not realize about small examples. If you choose the right example, you can, through that lens of a small example, you can actually see the techniques you need to apply to a larger system. More importantly, it can teach you how to keep things small. Every single one of the examples, they're all standard, I have actually used in production or used the testing techniques in production. In other words, saying, oh, I recognize this is this problem, it's just this big, but the same testing mindset is what I'm interested in. And I'm very much a believer in the idea that architecture happens at all levels. Sometimes people think architecture is just a big picture thing, and then they mess up the small picture and wonder why they have pain. The point here is, the bad news is you have to pay attention to everything. That's one of the things that makes software development both frustrating and exciting. So I'm going to concentrate on this aspect. I'm not going to say anything about the other kinds of testing, except many lessons that we can take from here apply elsewhere. I want to have a very specific focus, especially given that this talk is normally 90 minutes long. We have significantly less than 90 minutes. I will try and leave time for questions, but don't count on it. I am available for lunch. Okay? So, why have I given this talk with such a mundane name? Very simple reason. Structured interpretation of test cases. Let me just go and find if this thing has the focus, because I don't think it has. Ah, there it is. I've kind of patented after this book, Structured Interpretation of Computer Programs, which is kind of a computer science classic. Because I thought that this was quite a good way of trying to approach this question of why do we do this? What is the purpose of all this stuff? Now, clearly, one aspect of testing is one that I covered yesterday when I talked about failure. We don't really want to have failure. We'd like to minimize that. We can't eliminate it. These days, I'm very careful about using the word minimize rather than eliminate. We see lots of slides which say eliminate this, eliminate waste, eliminate it. Elimination, we've got to get real. Let's bring the number down. If you can ever get to 0, well done, but it's very unlikely. So let's do what we can. But there's more to testing than just having fewer bugs. There's another idea here. It's an expression of intention. It's about how do we interpret this. I want to go beyond the idea of, my tests are green, that gives me some confidence. I've got a red test, oh, there must be something broken. That is an interpretation. It's useful, but it's quite small, and it's not the whole story. It turns out that testing can give us an awful lot more if we pay attention to it. There is a point here. Programs must be written for people to read and only incidentally for machines to execute. Although that tends to help. Let's not dismiss that. But the same is true of tests. We often treat tests as kind of being a second-class citizen. They're not real. It's not real code because it's not in production. It's a bit like scaffolding when you're putting up a building. Oh yeah, that's not really important. Oh yes, it is. You really can't reach the higher floors safely unless you have scaffolding and cranes and all these other things. You need all of this. Without this support system, you don't have a software system. All of your tooling, all of your config files, all of your tests, those are part of the system. We have too narrow a focus. It's a bit like saying, oh, here I'm a human being, I'm perfectly self-contained. Yeah, until you take away the air, the food, and gravity, and all kinds of stuff like that. It turns out that we are part of our context. All of this is first-class code. It deserves your attention in the same way that the production code does. The production code is merely a small footprint of a much larger system. So I'm going to quote, so this is a book that was finished under lockdown, 97 Things Every Java Programmer Should Know. I edited it with Trisha G. And I'm going to quote from local girl, Marit van Dijk here, using testing to develop better software faster. And so she summarizes really nicely what it is that we want from a test. And I like the way that she approaches this, because we are so focused on what does a passing test tell us, that we forget what does a failing test tell us. If all a failing test tells us is, hey, there's something that was passing and it's not, that's really not very helpful. I want more information. There's probably more information to be had. I want that failure to be informative. I want it to be meaningful to me as a developer. I want it to be meaningful to my colleagues. A failing test should tell you exactly what is wrong quickly without you having to spend a lot of time analyzing the failure. I'm sure we've all encountered, test 5 failed. What does that mean? And whatever happened to test 4 and 3? And, what is it with this test? What does it mean? There have been a number of cases where we're kind of left with a sense of mystery. Well, murder mystery in this case. Okay, something's dead, but we don't know who, what, and why. And there's an idea here, and this I actually had with a team a few years ago, as we were looking not at test 5, but at test 3. They had numbered their tests, 1, 2, and 3. We'll come back to that in a moment. What does the numbering tell you? It tells you the order in which they were written. Is that useful? No. Okay. Test 3 was an interesting challenge because I was trying to get them to name things more meaningfully. And they said, Kevlin, this is where your testing technique doesn't work. And I said, why not? We don't know what this test does. Wait a minute, you don't know what it does, so that's my problem. I think you've got this the wrong way around. I said, what happens? What does it mean when this test fails? And they said, we don't know. I said, what does it mean when it passes? We have no idea. Right, that is the root of our problem. Let's work on that. So this means, in practice, each test should test one thing, whatever we mean by one thing, an objective. Do not mistake this for each test should have one assertion. I keep seeing people making this recommendation. Please don't do that. Obviously, you don't want a barrage of assertion, but it might be one logical assertion which requires one or more actual physical assertions. Don't make it brittle with respect to the granularity of the assertion and your API and your choice of testing framework. Some testing frameworks are very expressive in their assertions. Some are less so. But there's one idea, okay? Let's see what that is. And that should be reflected in the name, okay? In fact, sometimes people like to start as a useful clarifying technique, but this is only a suggestion, it's not a rule. Start with the end in mind. Where do I want to get to? What am I trying to show with this test? Of course, sometimes with kind of more exploratory code tests, I'm just writing stuff and I'm just going to throw in some assertions there. That's absolutely fine. You're thinking on screen, you're thinking aloud. But when you come back to it to tidy it up, you're kind of like your stream of consciousness that has been dumped onto screen over 50 lines and is currently called test, please rename me. When you come back to it, say, what are the things I can pull out of it? What are the things that I have demonstrated here? And you'll probably find there's quite a few, and you can identify what those are. So never be afraid to make a mess that you know that you're going to clean up. Otherwise, obviously, we'd never be able to cook anything. Okay? Sometimes people kind of get so worried about, I need to produce, all my code must be perfect and clean. No, it can be as messy as you like, as long as the thing that you check in looks good. Yeah? Again, I refer you to cooking. Do not look at the kitchen when I am cooking. But what I produce should be decent. Okay, use meaningful descriptive names. Okay, right. We've got to be careful with such advice. We need to be more precise. Meaning, remember test 3? What does that mean? It means the third test I wrote. That's a meaningful name. Okay, we're going to have to do better than that. Fortunately, Marit goes more specific. She said, don't just describe what the test does. Tell us why. This can help us decide whether a test should be updated in line with change of functionality. In other words, why is this test breaking? Oh, because I've updated something else and I forgot to update this in line with new functionality. So it's not a bug, it's just an oversight on my part, okay? Or whether an actual failure that should be fixed has been found. Have I broken a constraint that I was unaware of? We need to be able to distinguish between these two cases. Important one, never trust a test you haven't seen fail. Are you actually testing anything? Or have you ended up with the equivalent of assert true, true? Yeah, there's a lot of cases with that. I get this when people say, oh, I'm going to allocate an object, something, variable equals new, whatever. Assert that the variable is not null. Well, according to the laws of the language, it's never going to be null. And if it does fail, you have bigger problems. So this also puts us in mind of things like our style of development. Now, I'm not going to really focus on this today, but I do want to touch on it briefly to understand the timing essence, the aspect of timing. Let's say I'm working on a feature. I want to talk about the testing approach that I might take. I want to give you a broad sketch, a sort of mental framework. Sadly, in the industry, this is still the most popular option. No testing is the most popular testing approach. Do not walk, please don't leave now with that as the recommendation. Just sit down for another minute. Okay, test long after development. Okay, where are we now? June? Yeah, I wrote some code in January. Maybe now's a good time to test it. That's a long time after. I have lost the context. I mean, it's good that I'm doing it. It's better than the previous option, but I've lost the context. I'm going to have to do a lot of rediscovery, a lot of detective work. Or my colleagues are going to have to do that discovery and detective work. Or they're going to say, hey, Kevlin, would you like to mob with us so that we can write tests for this? And they're going to discover that I've completely forgotten everything that I did in January. Okay? But at least we're making an effort. There's another aspect here, is that testing shows up on the radar. It shows up in our schedule. It's very visible. Therefore, sometimes people try to optimize it away. That is not what people mean by test in production these days, though. Be very careful. Test just after development. Everything's still fresh. I understand the assumptions. I've spoken to my colleagues about this. We're working on something. It's still relatively fresh, but I have a slight objective separation from it. There is still a danger that in my head, I've written this off as done. So imagine yesterday I finished writing some code, and then today I decide to test. There is a nice separation of a day or a lunchtime or something like that, okay? A mental separation, and now I can go back with a different point of view. I was inside the code, now I'm outside trying to talk about it and reason about it. So that can be very healthy, very valuable, but I haven't lost all the context. I probably still carry some of my assumptions with me, but in my head, there is still the danger that I mark this as done. Oh, I've done the code. Hey, how are you doing? Oh, yeah, I'm done. What are you doing now? I'm just doing the tests. Oh, tests are not part of done. See, there's a very simple thing we fool ourselves with. Are you done with cooking? Yeah, I've just been into the kitchen. You apparently have used every single dish and not put it away. Oh, yeah, but I'm done, except for the tidying up. Yeah? See, we do that all over. That's a human thing. Don't blame developers for this. This is very human. But nonetheless, be aware that this is both a strength and a weakness of this approach, just after development. Plain old unit testing is what Jacob Prophet used to call it. Yeah, just like the traditional approach. Okay, now let's get to the continuous testing. TDD is the most obvious example of this. But there's another thing, iterative test last. Either you lead with a failing test and you fulfill it, or you write a little piece and then you match it with a test. Either way, the idea is that you're interleaving your time. That's the thing that is the big, big difference here. It is continuous. So when somebody says, what were you doing this morning? Were you working on production code or test code? The answer is yes. Well, which one? Well, both of them. Well, could you specify which minutes you were? I don't know. It's like specifying, how much time did you spend putting semicolons in? And for those of you in semicolonless language, how much time did you put, tabs, spaces, let's have that war, in? The point there is, that's not how I divide my time. It's all continuous. It's in the flow. So let's just pick on an example here. I'm going to talk about what my favorite simple example, leap years, because in this it's incredibly rich. One of the things I like about this is that this is a beautifully arbitrary rule that you don't get to change. Okay? In other words, it's like business, which means that most people get it wrong, they oversimplify it, they misunderstand it. And it turns out that if I walk out onto the streets of Amsterdam and I ask most people, hey, can you tell me when is a year a leap year? Most of them will look at me and go away, you weirdo. But there are a few people who will give me some answers, and most of them will be wrong. In fact, I've been using this as a teaching example since the end of last century, one way or another. Even amongst developers who are fairly geeky and care about stuff like this, I would say it's only around 5 to 10% of people that actually know the full Gregorian leap year rule. So this is perfect. The implementation is not hard. It's just knowing what the rule is and then having my tests reflect that. So this is C#, so I'm going to do this in NUnit. Here's our starting point. Let's call our test test. Okay, well, at least we're testing. Okay, let's be a little more descriptive, although probably it's in the class name as well, and it's in the file name. Yes, this test smell. You've seen it. You know it. It's, is this thing correct? Is this thing working okay? Is it okay? Test that such and such works. If you have never done this, well done, because I know I've done it. But you're sitting there going like, yeah, that's a really bad, of course I'm testing that it works. There's an invitation there. It doesn't mean that the name is bad. It just means we have not yet discovered. Sometimes I use placeholder names. It's like I'm kind of moving towards where I want to be, but maybe I'm not quite there yet. The name is, treat the name as being very temporary. Okay, I'm trying to learn what this is. And then maybe I think, you know what, I put everything in one place. I need to put it in more than one place. This is not the way we do this. Let's start looking at the domain itself. What does the domain of years tell us? Well, there are leap years and non-leap years. In fact, technically those are called common years, but let's just stick with the term non-leap years. So this is a starting point. We're still not done yet, but at least I'm making an attempt to reflect my understanding. I'm not just testing that the code works. I'm trying to explain what do I mean by it works. That's the harder bit. You don't turn up on a new team on Monday and say, hey, how's it going? Oh, it's good. Here's all our code. Right, does it work? Your question is, what does it do? What's it supposed to do? How does it do it? These are much more complex questions. Tests are not going to give you all the answers, but they can help. They're part of that kind of like ecosystem of knowledge that surrounds the code. We want to have that informational content. Let's try and reflect that. And of course, your understanding improves with time. Now, here, I'm going to pick a couple of leap years, 2020 and 2000. Now, if I look at those, the reason that 2020 is a leap year is for quite different reasons for the reason that 2000 is a leap year. I might be tempted to separate these out. So this is one of the next test smells. People end up putting hard coding their examples into the name. Test 2020 is leap year, test 2000 is leap year, test 2022 is a leap year. Great, but what about all the others? You've picked some examples, but you haven't yet given me, the reader, a model of reasoning. All of these examples are valid. They each demonstrate a different aspect of the leap year rule. There are indeed 4 different aspects to the leap year rule. The problem is, I don't know what they are. I'm left with a sense of mystery. I could equally, so the first thing I'm going to do as well is I'm going to stop the repetition. Dry, don't repeat yourself. It's not about, sometimes people think the dry recommendation is simply about duplicate code. It's not, it's about duplicating information. Okay? Don't tell me what how do I know that this is a test? Everything's annotated test. It's probably even in a folder that's got the word test in it. It's probably in a file that has the word test. You know, use the bandwidth more wisely. And I don't need to say that it's a test. Now, I can be a little more expressive. Okay, I'm going to use underscores. Now, although that breaks with various language conventions that use camel case and Pascal case, these names are different. This is an important idea to recognize that just because you are using a language, so .NET has very well-respected conventions for naming. So we're stepping outside those. Why? For readability. Because what we're going to see is that our test names are more statements. Normally your method names, for example, are verb phrases or adjectival phrases. You know, your class names and type names are normally noun phrases. Here, we're actually moving to a different kind of part of speech. But also, these names have a different property. They're never used. They are never explicitly called. You never need to refactor these names. You write them, and then they are called by reflection. In other words, the role that they serve is different. Although the language is the same, These are not methods in the conventional sense. That's not their job. They don't do that. And this is important to recognize that you may be in a language, but the conventions you're using are slightly different. So for example, I'm speaking English. I was just messaging my younger son who's doing an exam today, and I messaged him in English. But the way that I messaged him was slightly different to the way that I would normally speak. And it's different to the way that I would write a blog. And it's different to the way that I would write a shopping list or tweet. In other words, the language has different conventions for different contexts. There are contexts where you're saying, this is production code. There are contexts where you're saying, this is test code. The rules of what defines good test code may be different to the rules of what define good production code. There's clearly overlap, but respect that. Our names are going to get long. It turns out that camel case is not a very good thing. It doesn't scale above about 30 characters. Okay? So I'm going to go with the underscores. Let's drop away everything else. Now, let's get back to these numbers. I mean, I could easily replace them with a bunch of other numbers. Now, the problem here is I've just given you more examples, but I haven't told you why. What is the leap year rule? Now we're getting there. Now I'm starting to tell you something useful. I'm explaining it. A year divisible by 4 is a leap year. A year divisible by 400 is a leap year. Okay, we're getting somewhere. Let's reorder this so that I start with the largest category. Notice that the order in which people often think of things is not necessarily the order you want to read them. You have to establish a reading order. Okay, even though the methods will be called potentially out of sequence, the way we read things is from the top to the bottom, in source code. That's going to be. So what's the narrative for this? Sometimes there's a natural narrative. If I'm dealing with an object that has a life cycle, well, we start at the beginning of its life. That feels very natural. If I'm dealing with something that deals with a lot of data, so I've been doing some work with some folks who do a lot of numeric computing, high-performance computing. So a lot of algorithms on a lot of arrays or matrices. Well, let's start with the easy things. How does this algorithm work in the empty case? Okay, start easy. What about with one item? What about with many? What about with many that are like this? What about with many that are like that? In other words, build the story. Start from somewhere simple. Make sure that you have that pinned down. For leap years, it doesn't have a natural kind of zero or life cycle. So here I've chosen, potentially arbitrarily, but I think quite reasonably, I've chosen the largest category. Most years are not leap years. Most years are not leap years because they're not divisible by 4. So let's start with 75% of years. We're done. First test case. Awesome. Now, because when people do this, they latch onto the thing that they think is important, which is leap years. That's normally the first test I see people writing whenever I do this in a workshop. They test 4 leap years. Actually, most years aren't leap years. So I'm going to change the sequence here. But also people have a bias. A year divisible by 4 is a leap year. Then look at the next one. A year divisible by 100 is not a leap year. Well, wait a minute. These two statements cannot simultaneously be true if I'm using base 10. Let's just assume that I'm using base 10, okay? I don't want to keep restating that. Those statements can't be simultaneously true, given my understanding of mathematics. So clearly, I've done that human thing. You know the way that sometimes you say, oh, I always do this, oh, I never do that. Humans exaggerate. We pick the common case and make it 100%. But it's not 100%. So let's be more precise. A year divisible by 4 but not by 100 is a leap year. Okay, we're going to need to resize. Okay. That is the rule. Now I've got mutually exclusive categories. That mutual exclusivity is also important in the larger scale, particularly where you're dealing with business rules. When somebody has, I'm testing this business rule, and you say, oh, okay, cool. So what's this test? I'm testing this business rule under this slightly different convention or this slightly different context. Well, wait a minute, what was the other one then? So tell me what that one is. Find the name that says what this is. There are other naming conventions that contain the same information. This is Roy Osheroff's naming convention that he talks about in the art of unit testing. Okay, this is basically the unit of work, the condition of call, the expectation. If you look at this, you will realize we've used conventions differently, but it has exactly the same information. For me, I am most interested in the information. What am I learning from this? You can even use the kind of BDD approach, using should in front of everything. Again, it's got exactly the same information. You know, I have a preference for a particular style, the propositional style. I'll come back to that in a moment. But I don't really care because all of these contain the same information. They're all better than test 1, test 2. They're all better than test that is leap year works. They all contain the same information. Now, I'm never very keen on should. As my wife points out, she says, wagging her finger at me, that's something you software people, you computer people, do a lot. She says, that word, I hate it. Whenever somebody involved in software says should, that's really bad. Oh, it should work. Yes, but it doesn't. Yeah, but it should. That is the least helpful word ever to be uttered by a person in software. So no, I don't think it's a good practice. And the BDD community can quite happily disagree with me, even though they're wrong. They can have their own opinion. Some people react to that and go, yo, must. No, we don't need that. We can just keep it really simple, just like is and is not. Let's just try and find our statements of truth. Now, one of the values of this, here's a simple implementation. Now, this also explains, by the way, why, oh, by the way, I've seen this implemented in some staggering ways. This is one line, but I've enlarged the font. And in fact, if you use an expression, a body, then it's really short in C#. I have seen this implemented in 28 lines of Python. It was a work of art. But here's the point. Once you've got tests, you can refactor freely. But this also demonstrates why people struggle to remember the leap year rule, why I like it. As a simple example, because it's got an and an or, and a not. I mean, good grief, we've just used all 3 Boolean connectives. That humans aren't good with that. We're really good with and on its own. So I've been at GOTO on Monday and Tuesday and Wednesday, and we're really good. Lots of ands in a row. Don't mess it up with any other connectives. Okay? And the sun will shine on Monday or Tuesday or Wednesday. Fine, it's all ors. As long as they're all the same connective, that's fine. What really messes us up is you put an and and an or in the same thing, and then you throw a not in. It's just like, nope, sorry. That's just not how humans work, even software developers. Okay, anyway, back to the code and the tests. All these tests pass. But notice their names. The names, I'm not going to give you a guarantee. I'm not saying that, of course, it works, because you can't really test, you know, that there are no bugs. But what it does is that passing tests raise your level of confidence. It does not offer certainty, but it raises confidence. Have I got no tests? I've got no tests. Less confidence. More tests, more confidence, yeah? It's this kind of simple thing. But we want to focus on the quality, the informational quality. What I'm saying is when this is green, that statement has a reasonable probability of being true. I'm saying that a year not divisible by 4 is not a leap year. You know, that's what I'm saying. It's a statement about the code. It's a proposition. Let's implement rather than Gregorian rule, let us implement the Julian calendar, which it really is every 4 years. At that point, we discover that one of these no longer works. A year divisible by 100 but not by 400 is not a leap year. The reason I like this naming convention is because when something fails, then it means the opposite is true. Apparently, a year divisible by 100 but by 400 is a leap year. That's what we learn from this statement. So in other words, the proposition is demonstrated to be false in this case. So there's a point here about communication. Nat Pryce and Steve Freeman made this in a session that they ran at XP Day in London many years ago. Are your tests really driving your development? And they said for test to drive development, they must do more than just test that code performs its required functionality. They must clearly express that required functionality to the reader. That is, they must be clear specifications. In other words, this idea is your tests are specifying. So you can use the language of specification and thinking of specification. If you come in from the BDD angle, some of this will be very familiar to you. But a lot of people make a false separation between the ideas of BDD and the ideas of TDD. They overlap. They come from the same source. It's all software. So let's take it a step further. What I'm doing here is I'm structuring, given the constraints of the language, and let's drop away things, I'm using a namespace as a container. I could also use A class is a container, nesting of classes. What I'm now doing is I'm grouping things. I'm saying, oh yeah, there's a leap year spec. A year is a leap year if it is divisible by 4, but not by 100. A year is a leap year if it is divisible by 400. A year is not a leap year, and so on. This has an interesting, there's two things that are interesting about this. One, sometimes when people say, oh, my names are getting really long, even though you're not calling them, you still have to read them. But they are not arbitrarily long. They often contain repeating parts. What do we do with repetition? We extract it. So in other words, when you start seeing your test cases, and this is something that people often, this is a step that people often miss, they end up with a test class that has 100 test methods and think, oh, I'm doing good work because I'm doing tests. Yes, you are doing good work, but it could be better because 100 methods is still 100 methods, and that's not easy to read. So give it some structure. Give it some shape, okay? You take advantage of the fact that we're really good at differentiating levels. So put things on a level. And now I can say, oh, the commonality is that this is a classifier function, or it classifies stuff. So what's the classification? Years are leap years or non-leap years. Group them accordingly. Use that second dimension. And I've got data. I've got an example here, but I can take it further. These days, most testing frameworks, not all, but most testing frameworks will support some kind of parameterization. They can be more data-driven. Okay? And some are better at this than others, but the idea is that now you've got the opportunity to use representative data examples and really kind of express. Here's some examples. We like examples. It's just like, yeah, 2020 was a leap year, as was 2016. I don't really remember year 4. I'm not that old. But 4 is the canonical year that is divisible by 4. And I can do this with other connectives, divisible by 400. I can even set up this range operator, 400, 800, 1200, 1600. So immediately, I've got far better value coverage, but I'm also trying to choose examples from the domain. Your examples may not be simple integers. You may have much richer and more complex examples. Most testing frameworks will allow you a way of getting those in. But this is the way you build it up so that people can look at that. And importantly, somebody who is not a programmer, but maybe a domain specialist, can look through and go, yeah, those look right. Always remember that people can actually read more than you think they can read. Okay? They might not be able to read the curly bracket stuff, but they can really spot the words and the numbers. There is no doubt about that. It's like if you look at a newspaper in a language that you can't read, you will still pick out, oh, that's a name, that's a country, you pick out all of these things. So work with the way that people read this stuff. Take advantage of that. So we've got a nice classification here. Let's organize the way that we understand the kinds of coverage that we might have. There are common cases. There are also simple cases. So this is a really kind of a simple checklist. How do I check through things? Common cases and simple cases. Some simple cases are common, but not all. So this is a Venn diagram. But there are 4 categories. Boundary cases, the edge cases. Often the things that happen around the empty state or the zero or the upper limits or whatever they are. Include those. Some of those are going to be common. Some of them those aren't. They're often simple, but not always. And error cases. Just as a small note, this is the correct way to draw a Venn diagram with 4 sets, such that all combinations are possible. The one that you normally see on the internet, no, that's not right. The Clover version is not correct. I like to think of this as a tulip, and this seems strangely appropriate. I call this the kind of like the tulip of coverage. But let's talk about the error cases. So I'm going to arbitrarily say we're creating our own calendar. Okay? If you want to deal with real calendar problems, good luck. Calendars are, humans and conventions for telling time are difficult. But let us just say, for the purposes of this, I'm creating a calendar. It's a proleptic Common Era Gregorian calendar. In other words, it is backdated, Common Era, year 1 onwards, and we're basically saying that it has always existed for that period, but we're not supporting anything outside that. Okay, so a year is not supported, so I've created this concept of a calendar. I've created a calendar right here. If it is 0, I'm going to focus on 0, because 0 is often special. 0 is often overlooked. People even debate whether or not there is a year 0 in the calendar. You probably have an answer in your head. it's probably wrong. The answer is it depends. If you got that, well done, because it depends which calendar you're using. The calendar that most people in the world are using does have a year zero. Yeah, a lot of people say, no, we're using the Gregorian calendar. That doesn't have a year zero. No, you're using the ISO 8601 calendar. You just didn't know it. Yeah? It's like I've been breathing air all my life. And even if nobody told me, I just didn't know it. So, yeah. And then there's the negatives. I'll leave those out. Those are being excluded. I'm going to sample those. But while we're here, is your integer bounded? I talked a lot yesterday about boundary cases. There is a minimum value. Show it. Yeah, this one's not supported either. I'm going to keep 0 distinct. I could fold 0 in and basically say non-positive, but I want to make this visible. Sometimes we separate test cases not for reasons of coverage, but for reasons of emphasis. Just as you would write something in an email, if you want somebody to read it, give it its own paragraph, put it in bold, make it visible. Oh yeah, we've accounted for year 0, don't worry about it. But because of the naming style, it invites me to think, wait a minute, if I've talked about when it is not supported, I'm missing something. What about when it is supported? It's implied, but it's not explicit, that positive years are supported. It's implied. I'm expecting the following test to pass, even if I'm doing TDD, because I just want to say, yes, your assumption is correct. I want to confirm that it's not just something you have to guess. And I'm going to choose 2 ends of the scale. I'm going to choose the smallest positive integer, and I'm going to choose the maximum one. One of the things I have found funny is, and again, remember where I said that you can normally see through this lens the habits of many developers. Whenever I run this as a training lab, the number of times I get people arbitrarily put in a limit, an upper limit. It's not in the requirements, and they don't have a test for it. Normally it's around 10,000. Normally an exception is thrown if you choose a date that is 10,000 or beyond. But the point here is I want to say, so this is the case of developers inventing behavior. Of course we're going to do that, because developers are creative. What else were you expecting? But the point here is I want to confirm, no, it's all the way up. So we've got quite a nice model here when we drop away everything. That kind of works quite nicely. So let's move on to something else. I've only got a couple of minutes. Let's talk about FizzBuzz. That well-known enterprise. Actually, there is an enterprise FizzBuzz. If you have not come across it, Google Enterprise FizzBuzz. Now that is a work of art. So FizzBuzz is a counting game and it's a drinking game. FizzBuzz of 1 is 1 as a string, of 2 is 2, 3, oh, it's fizz. 4, it's just 4, 5 is buzz. Divisible by 5. Fizz, yep. 7, yep. And then FizzBuzz, divisible by 3 and 5. It's not the world's hardest, most challenging piece of software, but you'd be surprised how challenging it can be. Now, the interesting thing is, how do we implement it? Well, I can implement it like this. A lot of developers are always, so I've got some Python here. A lot of developers are always delighted to discover this accumulated effect. Oh, isn't it really cool? I never actually have to do the FizzBuzz case. This it feels cool. Actually, there's some problems with it. I'll come back to those in a moment. And then there's this case, which actually is the more functional of the two. It's the more structured of the two. It involves no intermediate state, no control state. I personally prefer this, but I'll also give you a reason why you should personally prefer it as well. But it allows me to talk about coverage. So Brian Marick observed and he was quoted in a blog by Martin Fowler, I expect a high level of coverage. Sometimes managers require one. There's a subtle difference. Don't use it as a control. Coverage is terrible as a control thing. But it is information. Sometimes we just need information. It's like, how are we doing? But the minute we set a target, the nature of the numbers changes. Their purpose, their role, and how people experience them and relate to them changes radically. So let's talk about that coverage. That's the first example. What I'm going to do is I'm going to highlight the fact that there are multiple forms of coverage, and then we'll kind of close. Assert FizzBuzz of 1 is 1. What kind of coverage have I got from that? Well, It turns out when people say coverage, it's as if they think there's only one form of coverage, and that's the problem, is that often it's because we don't like to have long phrases, we will often just shorten. The most common form of coverage people are talking about is statement or line coverage. The two are almost equivalent, but I'm going to treat them as if they were. But that's not the only form. There's a lower form, function coverage. Did we even call the function? Okay, we called it, yeah, 100% coverage you can claim. As long as you called each function once, you have 100% coverage. Are you sure, Kevlin? Yes, 100% function coverage. Oh, you mean there's more than one kind of coverage? Yeah. I've got 50% branch coverage. Every if describes two options. There is always an else in an if. Even if you don't put it there, there's still an else, because there are two paths you can go by. And I'm not going to quote the full Led Zepp, but feel free to do that as extra research. So the point here is there are two paths, two branches. I've got 50% branch coverage. There are 3 branches, I have taken half of them. Or 3 branches, I have taken half of those options, okay? I've taken the false of the first one, the false of the second one, and the true of the third one. But I've only got 25% path coverage. In this case, that's the number of possible paths I can go through. Each decision point gives me 2. That's 2 times 2 times 2. There's 8 paths through this, potentially, kind of. It doesn't actually work like that because of the values. So there's actually really only 4 paths because of the interactions of state. That's the issue. Now, that second thing now gives me 100% statement coverage. For a lot of people, 100% means done, go home. How are we doing? I've got 100% branch coverage. Come on, Kevlin. Yeah, but 50% path coverage. And you know, by understanding the nature of the problem, that there are 4 categories, just as in leap years. So the one thing I want you to walk away from is however many categories you think there might be more. There's always a wrinkle. There's always an exception to that. It's not just leap years and non-leap years. There are 2 cases in each one. The same for this. You know we haven't seen all of them. We've seen numbers and FizzBuzz, but we haven't seen fizz or buzz. Let's go to this one. This one's much more honest. It doesn't have intermediate state. This is an interesting thing. This function is simpler. It doesn't use control state or variable state. And it's also more honest. At this point, I have 25% path coverage. I have 25% branch coverage, but more importantly, 62.5% statement coverage. Now I add another test case. I'm at 75% statement coverage. Oh, we're not at 100%. We were last time. And now we're all at 100%. It turns out if you use a more functional flow style, in other words, something that could be reduced potentially to an expression rather than something that accumulates state, just watch out for this, because we are normally working in imperative languages, and it turns out that this kind of coverage statistic can kind of mislead you into thinking you have better coverage than you do. So, that is the important observation. It's very easy to use the numbers and mislead yourself. And that becomes the key. So I will close with the observation of what would tests for this look like. Because I recognize I'm standing between you and lunch, and that's really not a good thing from the perspective of the developer. Let's phrase this one out. What are the properties we're interested in? So this is property-based testing, effectively. Every result is FizzBuzz, or a decimal string. Is that true? Yes, it is. Have we understood the domain enough? Yes, that's a true statement. Okay, if that fails, we've done something wrong. Every decimal result, 1, 2, 4, 7, etc., corresponds to its ordinal position. In other words, we don't expect to find 1 at index 33. Okay, there's a 1 should be at 1, and so on. Every third result contains fizz. Every 5th result contains buzz. Every 15th result is FizzBuzz. A lot of people stop here. This is one of the reasons that property-based testing can be challenging, because it's not how humans think. This is not enough. You need this one as well. The ordinal position of every fizz result is divisible by 3. You need the reverse. Buzz divisible by 5, FizzBuzz divisible by 15. This now constrains exactly what we have. And therefore I can write, this is one of the reasons I chose Python, because the difference between pseudocode and Python is only a few characters. These are all the properties that I want for the data set that I've got, and I want to assert that they are all true. So it's not the world's most sophisticated set of testing, but in that, what we can see is we can see that there is a way of thinking that is thorough. And it moves us beyond the classic 1970s view from Niklaus Wirth, the inventor of Pascal. He wrote a book called Algorithms plus Data Structures equals Programs, which must have infuriated his publishers. I mean, these days, publishers are used to putting emoji in titles, but back in the 1970s, what? You've used a plus and an equals. We don't do that here, especially in Switzerland. But no, apparently they had to do it. We want to move to a point here where we have a much richer understanding of our code and the relationship with the non-code parts, the test code, the configuration code, all of those other bits and pieces, those little fragments, including your head and ADRs and bits and pieces like that. There is a larger system. We want to have a richer system of interpretation, and to feed that, we're not just testing for right and wrong. We're trying to communicate what we understand by right. Thank you very much.